Good morning, eighth graders. So, this is like the first official lecture of our human impact unit. And what we're going to be talking about primarily today is air pollution. So, the causes of air pollution and the greenhouse effect. Okay, we're just going to be focusing in on this. We might dive just for a second into one other little topic, but this is where we are at. So we are working with middle school earth science standards 3-1 and 3-3 primarily. Basically, by the end of today, you should be able to define air pollution, both natural and synthetic, define what global warming truly is, summarize what the greenhouse effect is, explain the types of fossil fuels that we use today, and list the possible negative effects all of these have on our planet. Okay, so that's kind of what's going on. The standards themselves, so construct a scientific explanation based on evidence for how the uneven distribution of Earth's minerals, energies, and groundwaters resources are results of past and current geoscience processes. There's a reason why only North Dakota, Texas, Oklahoma, like we're the only states with a large abundance of oil versus you just go next door to Minnesota, they don't have any oil. So this is all based off of geoscience processes that have happened in the past. Um, then you'll also be able to apply scientific principles to design a method for monitoring and minimizing the human impact on the environment. You are actually going to get firsthand experience with that within whole group. So make sure you have these notes in front of you and we'll get going. So you are going to identify your ecological footprint. What is your carbon footprint or your family's carbon footprint generally here on this earth? So we all emit carbon by literally just being alive. And that is something that the earth is able to kind of sort of take into consideration. It is the extra that we admit that starts to hinder our planet. So you will go to footprintcalculator.org/home/en. I'm going to do a whole video on this because there are some questions that get a little like, I'm only 14, how am I supposed to know this? Which is fine, okay? There are generalized numbers that we can use. So I'm going to explain that in a separate video, but what I want to do is I want to explain some of the terminology that you need to know. So, our carbon footprint calculator, there are three major terms that I need you to understand before you actually dive into that. So, first one is an overshoot day. An overshoot day is essentially if everybody on our planet lived the same exact way that we do or you do, okay? This would be the day that we would use up all of the Earth's non-renewable resources. So if everybody lived the way that you did each and every day, this date could be very, very early in the year. It could have already passed. I think when Mr. G did this just to kind of see like what was going on, I think we overshot it back in March. It is now April 30th. So that versus back in the 2020 shutdown, we didn't hit the overshoot day until nearly August. Just for how little people were flying and like cars were on the road. Like there was a lot more people going out and walking instead of, I mean, I remember taking Will in a stroller and went down to Dairy Queen, sort of a thing. I mean, he was little, but like we did that instead of getting in our car and going to Dairy Queen. Things like that. So yeah, that is an overshoot day. Second, our ecological footprint. This is the biologically productive area required to provide everything you consume. So this would be like taking all of the water, all of the fossil fuel, all of the food, etc., and put it into an area. Okay. So if you were to almost have like a stockpile, but it would take up a large amount of space. So the ecological footprint can be compared to a biocapacity, which is the productive area that exists on our planet. So in your country or region, including both personal and societal impacts. So essentially, how much space would you need throughout a year if you were to just put it into a little box? And then finally, our carbon footprints. Our carbon footprints are the amount of carbon dioxide emissions that we add to the earth each year. And when we talk about emitting carbon, we talk about it in the form of tons. Okay, tons of carbon each year. So those are the terms I need you to understand moving into the calculator. Okay, so this is where you're going to need to pause for a second. Unfortunately, jump over to a different video and watch how to do the carbon footprint calculator, and then come back afterward and we'll discuss a little bit. Okay? Okay, so back into the topic at hand, air pollution. So what is air pollution? Generally speaking, air pollution is a mixture of solid particles and gases within our air, so what we breathe. The particles and whatnot that are within our atmosphere can include things such as car emissions, chemicals from factories, dust, pollen, and mold spores that are just kind of sort of suspended in the air. We have discussed that clouds are essentially just water vapor attached to dust particles hanging up in the sky, and they've just collected enough. So that's all it is. There are some obviously on this list that are 100% natural. We can't avoid dust and pollen or mold spores. That's just what happens, especially this time of year. I'm taking allergy medicine every morning because of all the dust and pollen and mold in the air, which is natural. That's what is supposed to happen. What's not supposed to happen are the car emissions, the chemicals from factories and things like that getting thrown up into our atmosphere. There's a reason why when you go to warm up your car in the winter, you're supposed to open your garage door to let those emissions out, because can you imagine that in your confined garage? That's how we get sick and unalive sorts of things. So things like that. Will's awake. So apparently 5:40 is a great time for someone to be awake. So we're going to keep going through this. So we talked about particles and gases within our atmosphere that can create air pollution. One of the major pollutants that we don't really think of would be ozone, or O3, so 3 oxygen molecules, which is a gas.
Or O2.
We need O2 to breathe, you're right. So this is a gas. It's a major part of our air pollution within a lot of our cities. Ozone is great up in the stratosphere. This is what protects us from the ultraviolet light that the sun is producing and kind of throwing at us here on Earth.
Because it's a fireball.
Because it is a fireball. Okay. And all of this, but when it's down here at the troposphere level, it can be very, very harmful. So it's a major air pollution, and it starts to create what is called smog. We don't really experience that here in Fargo, North Dakota, but if you were to look at major cities, Chicago, New York, places like that, you're going to hear about smog alerts, and essentially it's just ozone that is down here at our level. Now,
Where's the thing with the guy that commands North Dakota? What is it? What that thing called?
Dude, I have no idea. I don't know what you're talking about.
But
let me keep. Shh. Some air pollutants are natural, and it's 100% okay that they happen. So we already talked about dust and pollen and mold spores, but the other natural things that I don't think we think about would include volcanoes and wildfires. Yes, they are catastrophic to the human population, but it's just a part of our earth that we have, like, it has figured out how to balance out those more active years versus inactive years, um, and things like that, to where that is considered a natural pollutant that our earth does know how to deal with itself. So that is air pollution. One of the major contributing factors of air pollution currently is our fossil fuel usage. So we are talking about natural fuels such as coal or gas or natural gas, petroleum, things like that, that form in our geologic past from the remnants of organisms that lived a long time ago. Now, fossil fuels, as we know, are non-renewable resources, which essentially means that what we consume in our lifetime cannot be replaced within our lifetime. So the idea is, yes, once it is gone, it is gone. Now, granted, fossil fuels will continue to be created for as long as there are living organisms dying off, but currently, and you'll see here in a video, that we're not even at the point of the remains of our dinosaurs actually becoming our fossil fuels. We are back hundreds of millions of years prior to the dinosaurs and living off of what came to us from the Carboniferous period. But that'll be something you kind of hit more so in your independent notes. So again, some examples of fossil fuels include coal, petroleum, natural gas. Okay. Now, all of these are going to equal into one thing, and that is our big buzzwords for this unit, global warming and the greenhouse effect. So let's talk about this. Global warming, different than climate change, but let's understand. Global warming is the general increase in the overall temperature of the Earth's atmosphere. Okay, this generally is attributed to the greenhouse effects caused by increased levels of carbon dioxide, chlorofluorocarbons, and other pollutants. Chlorofluorocarbons.
I said it right away.
Yep, you did. So that. And these are a big deal because all three of these major gases that we're talking about trap in heat, kind of like a blanket does against our bodies. Where some, like yours, to where I can feel some radiation coming off of Will right now, but not as much as what he's feeling against his skin. So these pollutants are trapping in the solar radiation and the geothermic radiation, because remember, our Earth does give off some radiation, and doesn't allow it to escape back into the universe. Now, this becomes a problem because if you have too much stuck, then you get an increase in temperature of the planet. So it would almost be like not just putting on a thin blanket, but putting on a heated blanket. So Earth's history, we've gone through multiple temperature changes, and it doesn't end well for a good portion of organisms. We learned in our geologic time unit that at the end of each major temperature change within the Earth, we lost 50 to 90%, or what was it, 97, 98% of all the living organisms on Earth. So if you can imagine, if this heat increase kept going, what would that do to the human race? We're not as adaptable as we'd like to think, and especially because adaptation happens over a very extended period of time. So that this diagram kind of explains it the best, where you have these wavelengths of radiation coming in from the sun to the earth, and they get trapped behind this invisible shield. And that's what is happening within our greenhouse effect. So yeah, not great. So this is the end of whole group notes. Please keep your CHAMPS expectations in mind as you proceed through the rest. And yeah, that's all I got. Okay, if you're here for lecture notes, let's keep moving. So this is just a quick little like Fossil Fuels 101 that I found on YouTube. But basically it is just...
So.
It's not going to play on here though, baby. So I want you to watch this. It kind of explains how fossil fuels are created, the different processes to get from petroleum to coal to natural gases, things like that. So if you are watching this, if you just pause right here, head over to Schoology, watch the next link, and then come back. We'll keep moving. So.
No, I want to watch it.
Okay, you can watch it after I'm done recording. Okay, so air pollution and its effects. We've talked about what it is, but now how does it start to affect organisms here on planet Earth? So there are 5 major hits, all from environmental, weather related, like acid rain and smog, to actual like animal and plant extinctions or harm, human health problems, and then finally back to climate change and global warming. So, negative weather impacts. So an increase in air pollution brings on weather that is not natural or typical.
Tornado?
It can lead to more tornadoes. Yep, but we don't have to worry about that. Okay, what I'm talking about primarily, and this happens quite often in larger cities, but it's not to say that it won't start happening in North Dakota. But acid rain. This is where water typically is fairly neutral when it comes to its pH level. But acid rain is when rainfall is made very acidic. So imagine like orange juice falling instead of just rain.
Orange juice.
Not as tasty though. Yeah.
Wait, if it's not gonna be tasty, add the pail.
Okay, so if it's orange juice where you have gross. Excuse you. If you have orange juice and you've added the peel, that's what's happening to our rain. So you could have almost like burning sensations. The biggest issue with acid rain isn't necessarily people getting hit by acidic water, but rather it is the harm that it does to our environment. So making lakes more acidic, hitting plants and trees, and that are also taking it in as its form of nutrients and things like that. We start to see a lot of those negative effects. Smog we talked about just quick, which is a mixture of smoke and fog within the air due to large amounts of coal burning in an area, mixing with smoke and sulfur dioxide. And remember, sulfur was that bright yellow mineral we worked with at the beginning of the year that smelled like rotten eggs. So that all of this leads to secondary pollution of our water, destruction of plant matter, and concerns for human health. There are already days with some of our population where we have to check what the air quality is, or if we have things like asthma or heart conditions or any sort of respiratory concerns, we can't go outside without proper PPE or just at all. So if you can imagine, if this little one developed asthma and now I'm having to track whether he can go outside and play because of the air quality index, can you imagine what my life would be like when we have those major air quality days, day after day after day?
After day.
After day? Okay.
After all.
How much did you cry and complain about going outside and playing last night? A lot or a little?
So much.
So much. Now, if I told him that he couldn't go outside and play, not because it was cold, mom had to make dinner, but rather because it's not safe for you to go outside, how well do you think that's going to go over?
I'm going to kick your boot in then.
Okay. Threatening harm to your mother. Thanks. So, those are the sorts of negative weather impacts. Plant, animal, and human health. When we have air pollution, we start to see effects to other living organisms. Where are you going?
Dad, give me that. Just want to stand right here.
You just want to stand? Okay. So animal, human, and plant health. So we see a big issue really start to take shape in animal and human respiratory tracts. So the idea of taking in a deep breath and pushing it out. Okay. We see a lot of, because it's air coming into our bodies with all of this other nonsense, we see a lot of respiratory issues, lung damages, things like that. If we can't get enough oxygen, no, thank you. If we can't get enough oxygen into our lungs, we start to see neurological damage because our brains need a certain amount of oxygen in order to
make life
and do what it needs to do. Skin irritation. We talked about acid rain. So if you were to take a little bit of orange juice, and if you were to put it on your skin, some people would start to see a little bit of red irritation. Similar idea to like when you eat pineapple.
I know when I eat it with watermelons, it doesn't taste good.
Oh, good. But when you eat pineapple, does your mouth start to feel goofy?
Yes.
Yeah. That's because there's a lot of acid and there's actually little enzymes that are literally eating your skin. That doesn't mean that we don't eat pineapple because it's still good. And in small amounts, it's really good. But if you were to do that and place it just on your skin, similar to like a sunburn, it starts to irritate it. Our endocrine disturbances and hormone imbalances, if we're starting to have all of these lung issues, skin issues, it starts to take toll on the rest of our body systems. And the first one usually to kind of get, hey, only a couple more slides. The first body system that really starts to take a toll is typically our endocrine, which is all of our hormone imbalances. And then finally, for animals and humans, we start to see an increase in vulnerability to other diseases. So on top of, if you already have asthma, maybe now you start to develop a heart problem because you're not able to get enough oxygen into your body and things like that. So not great. Now for our plants, we're talking about damage to their leaves, which is called chlorosis, or the lack of chlorophyll. So they're not as green, they get yellow. When plants are placed under stress, they don't flower, which means if they don't flower, they don't reproduce typically.
Good nutrients. Apples.
Yep, and apples are good nutrients for us. We start seeing damages to the roots because if it is air pollution causing water pollution now, those plants taking up that water is just damaging the most friable tissue that they have. That's why their roots are underground, is because they need to be protected. Like our brains are in our skull. They need to be protected.
What? I did not know that.
Oh, stop it. You did so.
I'm just kidding.
Prevention of transpiration. Stomas don't work the way that they should. And we talked about transpiration with our water cycle. And then finally, just low growth rates. They don't get as large. They don't produce as many fruit. We then start seeing an issue with the fact that we need plants in order to scrub the carbon dioxide out of our atmosphere to make it more breathable for us. They take in carbon dioxide and release oxygen. We take in oxygen and release carbon dioxide. We have a symbiotic relationship, but if our pollution is now stunting plant growth, we're just essentially starting to dig our own holes. So that is a big deal. So let's talk about the difference between climate change and global warming. So we talked about global warming. Okay, we've already defined it as the rise in global temperatures due mainly to
She was done that.
a rise in global temperatures due to mainly the increasing of concentrations of greenhouse gases in our atmosphere. So adding more CO2, adding more nitrous oxide, more chlorofluorocarbons, no thank you please, things like that. So that what that eventually brings on, because global warming happens. We've gone through a couple different stages of global warming and cooling. Hey, no thank you, or else you'll have to go away.
Damn.
So we've gone through a couple cyclings of global warming and cooling. That's why we have ice ages and things like that. It's not uncommon for our Earth to go through that, but what is uncommon is more of that climate change. So no, it's not great that our Earth is heating up, but it's also not great because it starts to increase changes in more of the measurable climate over a long period of time. So it affects the amount of precipitation an area gets, whether it's too much, not area zero, whether it is too much precipitation or not enough precipitation. We start to see that temperature difference, whether it is increased or decreased. I mean, some of our polar areas are experienced like significant decrease in temperature, which can be an issue because that means fewer summer months.
Okay? Maybe a zero too.
No more.
No.
Or living room it is.
Okay.
And then we start affecting our wind patterns, which, as we know, wind is what drives our global weather. So we need that to happen.
How many more slides?
2 more. This one and 1 more. So what do we use fossil fuels for? Well, as humans, we use fossil fuels for life. Everything.
Ow.
Oh, stop it.
That really hurt.
Okay, I'm sorry. So we use fossil fuels to create electricity, to heat our homes, for transportation. We use fossil fuels to create plastics and candles and beauty products. Nylon, so synthetic.
My eye is crying. My eye is crying.
Okay. We use plastics essentially for our synthetic materials. So if you're wearing more of an athletic style, more of a athletic sort of top or short or whatever, it's made out of fossil fuels. Different textiles, unless you are getting 100% bamboo or 100% cotton or silk, you are wearing fossil fuels. So with that in mind, if our fossil fuels were gone, how is this going to affect your daily life? What sort of products would you no longer be able to use or purchase? And then does this change any of your minds about our use of fossil fuels? I'm not here to change your mind. I'm just here to provide you with information. I'm not saying you now go home and you're like, we need to change this, because it's very hard. Society today has made it very challenging for us to move away from our fossil fuel dependence. Are there more mindful choices you can make? 100%. What do we do when we leave a room, Will?
Shut off the light.
Shut off the lights. What do we do with the water when we're brushing our teeth?
Shut it off so it doesn't flow.
Make sure our water's not flowing while we're brushing our teeth. There are sensible options like that. I gave the example in class of using LED light bulbs instead of incandescent. We can plant more plants and trees and things like that. I have seedlings
Mom,
going.
Today, I wasn't in my whole class, and then one part I had someone planting a tree.
Yeah.
In the middle of the yard.
So in this room alone, we're just in my little office. I have about almost 60 some seedlings going in one window.
66.
Okay. Seedlings going in one windowsill. I have a giant snake plant that needs to be broken apart into smaller ones. I have 2 spider plants. Like, there are things you can do. Now granted, my yard, I don't have any trees in other than my windbreaks. We're hopefully going to change that in the next year or so. But like, you can do small things like that to help our environment. Am I still dependent on fossil fuels? Yes. That's probably not something that we can make a change with until it becomes more accessible to us. We discussed during a lot of our scientist circles about how electric options are just not affordable to the everyday people. And as discussed in some of our other videos and things like that, if we are burning fossil fuels to create the energy to make those electric options more affordable, it's doing the same damage that vehicles are doing. So things like that. Things to be aware of.
Fires in vehicles?
Yeah, there is technically a little bit of fire in the vehicles when we put gas in. We'll talk in a minute. So, things like that. So I just want you to think on it. Be mindful of it. See how it does impact your life, if there are minor changes you can make. If you are not a person who turns off their lights when they leave a room, maybe you start doing that. Okay? Things like that.
I always do that because...
Baloney. I bet if I go upstairs right now, a light is on in your room.
Actually, it's off.
Okay. Awesome. Well, thank you so much.
Phone.
Thank you so much, 8th graders. We will talk soon.
Look
Will, what do you say?
Bye-bye, 8th graders.
Bye-bye, 8th graders. Let us know if you have any questions. Thank you.
See you later, alligator.